Paul, my colleague, and I are from Oracle. And in fact, if you go to the next slide, you'll see that this is actually true. Okay, now that we've done that, let's go on. I was actually a little bit worried. Yesterday, I was on my way here from San Francisco, and as sometimes happens when you're traveling, I had a little bit of a problem. And so I was kind of worried how this would go, but then I was able to just, kind of take a deep breath and look at the title of the talk today, and of course, then we found the solution. Okay, so what are we here to talk about today? As Jørn said, I have a predilection for talking about Java, so I thought I'd do that. A little bit of a surprise, I'm sure, for many of you. But the idea here is not only to talk about Java, but to sort of try to give you some insight into what goes into creating a programming language and evolving a programming language over time. And of course, what we're talking about today is not just any programming language. It is one that, according to many measures and surveys and so on out there, is one of the, if not the most popular programming platform in the world today. And that means there are a lot of people out there using it. There are a lot of developers, there are a lot of enterprises, and there are a lot of end users. So the evolution that we go through can't be one where we just sort of jump on, whatever the latest trend is. And I don't think anyone would accuse us of doing that. On the other hand, it can't be something that is too slow and falls too far behind. So I wanted to talk, first of all, a little bit about, if we sort of go back to the history and kind of the roots of Java and where we started out. So 1995, this is what Jørn was referring to with James Gosling and a small team in what was then a subsidiary of Sun called JavaSoft. Had some technology. They were looking at a bunch of different things to use it for. You can read more about it in some places. But as you can see, the aim was fairly modest. A simple, object-oriented, distributed and interpreted, robust, secure, architecture-neutral, portable, high-performance, multi-threaded, dynamic language. All right, well, since the bar was set so low, of course, it was easy to turn this around quickly. In fact, of course, it took a while for Java to get, to kind of the size and shape that we're used to seeing today. But I think that what was kind of nice to see there was that many of these things, many of the aspects that are things that people tend to find valuable in Java today were actually things that were thought of from the beginning, right? These were not things that were sort of afterthoughts. And this is something that you can see, when you look at languages out there and you kind of look at, what was the focus of the people who created it when they created it. Often those questions are addressed, and then if there are ones that you kind of come along and deal with afterwards, those are really, can be kind of a challenge to do. So when we look at sort of some of the benefits of Java that we see, one is that it's relatively simple. There's not a huge amount of syntax. It's fairly simple to get started with and kind of learn the way that it works. And then once you've understood that, there's a lot of learning to do in terms of the APIs and so on. But basically, that's all fitting into a framework that's kind of easy for you to understand. Stable. This is something that we see today. Once again, part of the idea here was, and remember, if you look back to 1995, people were using lots of technologies then, but some that were most prevalent were people writing their own native code, writing C applications at the time, C and C++. And one of the big challenges that people had was exactly this, that they would write something, it would all be great, they would deploy it, and then they would get some segfault somewhere. There were some memory errors. And those kinds of things tended to be very, very difficult to debug. Java, by doing its own memory management, took a lot of that out. Now, of course, there were still some issues, especially in the beginning, but those by and large got shaken out fairly quickly. All right, fast. Well, as Jorn said, there were some questions first off, and when Java got started, as something that was interpreted, there were a lot of questions about this, and that's actually a sort of reputation that hung with Java quite a while, even when the truth had changed, and the truth did change fairly rapidly, in part because we went beyond having everything be interpreted to actually having some pretty good JIT compilers. And in fact, those have continued to improve over the years. And we'll get back to that in a minute. But I think that basically the state of where things are right now is that the JIT compilers for Java are really, really, really good. If you look at the machine code that they end up generating, it's actually, in many cases, far, far better than what you would come up with yourself. And there are some good reasons for this, right? One is that it's been tuned a lot over the years. Another is that we work very, very closely with people creating the hardware in order to make sure that as new generations of hardware come out, the JIT already knows about them. So you're not having to go back and rewrite and sort of hand polish a lot of very low-level code. What's happening instead is that as new hardware with new features is coming out, people have already been working for quite a while behind the scenes to make sure that your Java program can take advantage of that without your Java program having to change at all. So scalability here, once again, this turned out, Jorn and I spent a lot of time trying to implement Java things for the client. Of course, what history has shown us now is that one of the places where Java became most popular was really on the server. And this was in part because of the scalability aspects that we saw. And that, I think, was kind of a balance of inherently worrying about things like threading. It was in part by having some layers on top with things like Java EE and Spring later on. And then I think it was also in part because this was kind of an industry that grew up around dealing with the scalability problem. And if you were really, really focused on native code in one area, dealing with a lot of these issues turned out to be very hard. Whereas Java turned out to be a nice kind of level to describe things and have some support from the platform for worrying about scalability. Easy to read and maintain. This actually, arguably this should have been one of the first bullets on here, and I think this is something that I can't stress enough. Brian Getz, the Lambda architect, usually likes to say that you write your code once, it will need to be read, if it's good, probably hundreds or thousands of times over its lifetime, and so it's great to make things easier to write, but it's extremely, extremely important to make them easy to read. Because as you're maintaining, as the code is going on, if somebody's trying to understand the design and add to it, if they can't read it, then it's hard for them to do that. Okay, so choice of compatible implementations. This is something that I think has been a unique strength of Java throughout the years. And I think, to Sun's credit, in the very beginning, this was something that was thought of, that basically, it was not going to be a small set of, 35 people who were going to worry about taking this thing that had the ambition of being platform neutral and porting it to all of the different environments that were out there. Right? I mean, one way is you could try to do that yourself, and you would probably get a little bit of the way down the road, but eventually you're going to get to the point where if you want this to be truly ubiquitous, you want it to be out there on lots and lots of hardware and operating systems, you really need help. And so what's the best way to help? Well, to enlist the people who are experts in those areas. And they need to have, kind of an incentive to do it, and they also need to be able to do it, and they need to be able to make sure that when they've done it, that it actually is really going to be compatible. So Sun put a lot of focus on this in the beginning. They originally had something called a licensee program. This fairly quickly evolved into something called the JCP, and that actually is something that I think yesterday had an anniversary. I think it was a 15-year anniversary that they celebrated yesterday. And so this is basically a group in which standards for Java are created, right? And so even the Java platform is something that, it's not just, my group sitting down and saying this is how it will be. It's a collaborative effort with a lot of people, a lot of input from different individuals and different organizations and different companies, trying to make sure that the specification for this will be good. And then the specification comes with a compatibility test kit so that, if you're IBM or if you're HP or if you're a university, you can take this, you can make changes to it, you can do your own implementation, you can make sure that what you've done is actually something that's going to be compatible. Okay, a great software ecosystem. The evidence is here all around you. When you look at all of the companies that are out there, all of the packages that have been written, all of the libraries, this, I think, is one of the things that made Java strongest over the years, is the fact that it was pretty easy for people to put things together and put them out there. And in fact, Java programmers have a very unique mindset in terms of using other things. There was somebody who was telling me just the other day, he was like, one of the things that I find when I look at very low-level languages is that the first thing that anyone does is, they create a new project and then they go and they implement HashMap. Because that's what you do. And of course in Java, this is the kind of thing that nobody would think of doing, because that there's a great implementation of HashMap. That there's one that's there that's getting better. In fact, that there's a complete set of collections, and that the smartest thing for you to do as a programmer is not necessarily to sit down and implement your own. It's to figure out, is there a good one out there that I can use? How can I use that so that I can spend my time worrying about the thing that I'm doing that's unique and different? And then this is back to what I mentioned before, future-proofing, right? So what I mean by future-proofing is not only that the underlying implementation continues to get better, so that your Java program becomes better without your having to do anything. It's also that the rest of the implementation of Java continues to get better. So as we go along, as we have new versions, what you found by and large, and there are always some kind of problems with this, but the backwards compatibility story for Java, or the sort of forwards compatibility story, has actually been very, very strong. And so I'm always amazed. I go and talk with people, and I've had people who tell me, hey, we had this application, we were running it on 1.2 for years, we never touched it because it was just working, and then we thought maybe we should have something a little bit more recent, and so we downloaded Java 7 and we ran it on there, and it ran the first time. So I think it's great to see that kind of thing. Of course, what they then went back and said was, by the way, not only did it run the first time, it also ran far, 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 far better and faster than it had when we were running on the earlier version. So speaking of versions, let's go back and kind of rewind here and look a little bit at what sort of happened over the years. So as Jorn mentioned, he was talking about 1995, and so in that case, you were very early on. There were beta versions and so on, but of course the first version that came out was in 96. And then as we went on, fairly quickly afterwards, the 1.1 version, and that fixed some of the sins of the 1.0 version. 1.2 took quite a bit longer, and this was actually something that really extended the platform quite a bit. There were a lot of the APIs that we're used to now were actually not even things that were introduced until 1.2. 1.3, there was a lot of focus in this one on kind of slimming things down. We did a bunch of work on making startup faster by finding ways of delaying class loading and other things like that. We did a lot of overall work on performance and size. 1.4, of course, came along a couple of years after that, and you can see here the time between releases is getting a little bit longer. With 5, we had generics and other things, and that was also similarly long. And then finally, JDK 6. And after that, things kind of ground a little bit to a halt, right? So JDK 6 was actually the prevailing version for quite a number of years. I think it was 4.5 years in all. And part of the reason for that was a big event that happened there in the middle. Okay, go on. And of course, you know, I say this with a little bit of a twinkle in the eye, but something like an acquisition, it actually does cause, you know, quite a bit of churn. And on the other hand, it's also an opportunity to look at things, look at the direction, and see where things were going. And one of the things that we did there was we looked at it and said, okay, this was in, you know, by the time that was done, basically all in, you know, sort of late in 2010. And so it had been 4 years since JDK 6 had come out. Now, there were a lot of reasons why, you know, there weren't new versions coming out. Not all of them were technical. There was a lot of, you know, engineering work that continued to go on. But things were sort of at a point where it seemed to be very, very difficult to continue to make progress. And I think this is one of the things that you see as a computing platform becomes more mature. Right? One of the nice and exciting things early on is there's a lot of churn, there's a lot of excitement, there's a lot of things happening. But as things become more mature, it can become, you know, there's a risk that it becomes harder and harder to continue to improve it. And part of that can actually be, ironically enough, the success of the platform. You know, the more people that you have out there who are using it and depending on it, the harder it is sometimes to make changes to it. And the more resistant people can be to that. Now, on the other hand, you know, there's sort of, you don't want to change too much, you don't want to change in a way that breaks things, but it's also not an option to stand still, right? Because the world is not standing still. The problems that we need to solve and that we want to use this technology to solve are continually evolving. And so we need to find a way to deal with that. So one of the things that we did then is, as we put these groups together, and in fact there were actually 3 groups. There was the large Java group from Sun, including the hotspot JVM group, and then there was also a group that came from BEA that created a JVM called JRocket. And in fact, the technologies that have been developed there turned out to be quite complementary. And so basically we took a look at like how could we combine these and try to get kind of the best of both. With the JDK 7 release, we took some of that combination work and we took a bunch of the work that had been done post JDK 6, and we said, look, let's kind of blow out the cobwebs and, you know, kind of get a major release happening again. We did also a bunch of work in the community. So, you know, one of the issues that had sort of tended to arise was there was some friction and, you know, differences of opinion. And so, in fact, it became kind of an important step to try to resolve some of those things. As an example, you know, IBM came and decided that they wanted to join the OpenJDK community and become a part of that. Apple similarly went and took the work that they had done porting Java to the Mac and donated that to the community so that there were things that could be done there. So that was quite nice. But really that was just a first step. You know, there were a lot of people who sort of criticized 7 saying, well, there's not that much that's exciting there. There's some nice stuff, but, you know, there's nothing that's revolutionary. And so, of course, you know, that actually was the intent, right? There wasn't an intent to sort of spend a long time and do something revolutionary. It really was about, you know, trying to get the machinery of getting releases going again. 8, on the other hand, is actually a release that we think is quite revolutionary and really moves the ball forward a lot. There we go, there's Java 8. Someone from Australia is going to start throwing things at me. All right, let's go. So, so this was quite nice. This is a headline on sort of what we think the state of affairs is now. This one is somewhat tongue-in-cheek. I think it's kind of funny that, you know, we have a Clinton-era relic. It just sounds like it's, you know, falling apart and morally decrepit. But of course, I think it's funny because we might see the same thing happening in politics soon. So anyway, this idea of it ruling the web, of course, is kind of a joke, right? I mean, one of the things that we know is that, you know, Java has been strong, has continued to be strong over the last 20 years. But what I think this really kind of points to is something different, right? It is that, you know, Java got to a point where the lack of continued momentum and forward evolution meant that it was no longer viewed as hip. Right? If you were a young programmer coming out of school and you were going to start at a cool startup in the center of some European town, Java might not be the first thing you would look at. In fact, it probably wasn't. And at the same time, what this article did was they went and interviewed a bunch of startups that had turned out to be successful. And they had started out going, oh yeah, Java, yeah, that's my granddad's language. And so instead they used something else because they needed to develop very quickly and do a lot of prototyping. And then what they found was that as they started to get traction, they needed better performance, they needed better scalability, and they were not going to get there with the technology they were using. And so what they did in a number of these cases was they went back and they said, hey, we like some of those aspects of this technology we've been using, but we need something else here. And so they moved parts of what they were doing, in fact large parts and very, very central parts of what they were doing, to Java. Okay? Okay, so where does this get us then on the roadmap principles? I talked about, the sort of need to consciously think about evolution, right, and how quickly you want to go. Well, for Java, it turns out that because, as I was telling you, there's sort of work on specifications so that you can have lots of implementations. There's also work on the implementation itself. These two things can be done somewhat independently. Typically, if you rev the spec, you need implementation of that. But you can rev the implementation separate from the spec. And so this is kind of where we are now. We've talked with a bunch of people. The general feedback that we get is, we want you to evolve, but not too quickly. So you've got one set of people who are like, hey, yeah, you could have a new version every month. Give me more features. That's awesome. And then you have, some enterprise developers who are like, oh my God, whatever you do, just don't do it too often. Because, every time you do this, we have to recertify, and it's a big pain. So where we ended up on this scale was, we think that about 2 years between major releases is a fairly good cadence. We think it's a fairly appropriate cadence for technology that's this mature. But keeping in mind that in between, you can rev the implementation and continue to make that better and better. So major releases every couple of years, minor releases on about a 6-month tick in between. And if you think back, this is exactly what we've seen. With 7, we fairly late on came into this model. With 8, this is exactly where we are. So 8 came out in March. There's an 8U20, which is in about August sometime. An 8U40 next February, roughly, and then an 8U60 sometime after that. If anyone buys me a beer afterwards, I will tell you about why they're called U20, U40, and U60. It's not necessarily obvious. And then basically looking at 9, about 2 years after 8. Okay? All right, so what's cool about 8? Jörn mentioned that there was a lot of neat stuff there. I'm going to go through this quickly, and then Paul's going to show us some real examples. So one of the things here is Lambda, which brings closures to Java, and the streams APIs. This is basically adding some things in order to help you use Lambdas within collections in a way that doesn't require a complete new set of collections. Okay? Date and time APIs. This is something that apparently it's very easy to get wrong. We've managed to do it at least twice. And so this is an attempt to rectify that. Compact profiles. This is really, you can think of it as kind of a step towards modularization. How many people are using Corba today? Yeah, but it's there. Anyway, that's what compact profiles is about. This becomes increasingly important as people are looking at smaller environments, things like Internet of Things, embedded devices, and so on. Nashorn. So this is basically a rev on and kind of a new version replacing Rhino, which was an implementation of JavaScript in Java that's been in the JDK for many years. That implementation was, getting a bit old, and so Nashorn is a new one, which actually takes advantage of the invoke dynamic bytecode. The first new bytecode that was added to Java after the initial days, this was added in Java 7, and now we've used it in 8. Flight recorder mission control. This is you can think of this as like a black box for your JVM. So this is the thing that helps you figure out what the heck happened when your server crashed at 3 in the morning and you didn't have full instrumentation turned on. Okay? No more permgen, and Paul will talk about that. And of course, there's a host of standards that we support, from accessibility to internationalization to security, things like TLS and so on. And then finally, developed in OpenJDK. I'm going to mention some more about that after we look at some code.
Okay, I'm going to show some stuff in the IDE. I'm going to sit down because I can't code and stand up at the same time. Otherwise, I can't do it. So, George talked about some features. So, how many people use Maven? How many people use Maven? Some? Wow, loads. How many people had to modify the Maven options because they're running out of permgen? Yep, we all done it. So if I do Maven minus version here, in there. So in Java 8, what you'll get now is ignoring option perm size, max perm size in there. So you've all set the Maven ops here. You probably all set these up. We've got your hands up now. You don't need to set those for Java 8 now. You can get rid of them. You probably set them about 4 years ago, then forgot about them. That's what I did. And now they're hassling you now, so you can actually remove those. Actually, when you go to Java 9, you'll actually get an error, and you won't be able to execute anymore. It will reject them. But now you just get nice warnings, so you can remove them, which is good. So that's my permgen demo. OK, let's talk about date time. So how many people have used the date time classes in Java? Now, have you used them server-side or client-side? Server-side? Use them server-side. Are they immutable or immutable? Mutable. So what happens when you get two threads working on the same simple date format? Do you get one half of the date from one thread and another half of the date from another thread coming in? I don't know. You quickly find out this is a pain in the backside to do server-side if you're writing HTTP servers. So what people usually do is they do this humongous thing here. How many people have stuck their simple date format in a thread local? Yeah, I've done this. It's like, and in fact, this is sort of, I extracted this out from the Jersey JAX-RS implementation I wrote. And in fact, you usually have to have about 3 date formats in when you're parsing HTTP headers here. So you have to stick this in a thread local, and you have to set it up like that, and it's pretty yucky. We can actually, before I get on to the date time thing, we can actually improve that in Java 8 if we really want to. So we've added a new method called thread local with initial. And this is actually something we added to 8, and we can actually take a Lambda expression. Rather than doing this anonymous in a class here and extending from thread local, we can actually take a Lambda expression like so. And I can copy this code here and stuff it in here. Put a semicolon there, because Java likes semicolons, and comment out that. So we can actually improve it a little bit, like so, and stick it in a Lambda expression. And this essentially target types this expression to something called a supplier, like so. And you call a supplier.get, and you get your simple date format out, like so. We can improve it a little bit more, or more likely, if you have existing methods around that supply stuff, what you can do instead is, I'll just, for demonstration purposes, create a method with exactly that same code inside. So say you have an existing method like this lying around. Instead of doing the Lambda form like here, you can just copy all that out, scrub that, and use a method reference instead. And then it gets a lot nicer. So we sprinkled a bunch of these methods around JDK 8, which will leverage these Lambda expressions and a bunch of new interfaces we've added. I'm not saying you should transform it like this in this particular case, but if you've got methods lying around already, this is a really nice idiom to use. So a little digression there. So what would you do with a new date time class? Well, you just do that instead. So which do you prefer? I think it's no competition. So the new date time class already has one for the 1123 RFC out there already. You can use, and it's immutable. You don't have to worry about threads. In fact, the date time API is a really nice API to use. It's designed all consistently immutable, and I think given the complexity of date and time, it does a nice job of not exploding out into a huge, massive API. It's really nice design. I encourage people to use it. I'll put this stuff on GitHub. I'm not going to go through this, but there's some examples here to show you how to use it in this particular case if you're interested in learning more. Okay, so let's move on a bit. So I want to talk a little bit about raising abstractions in Java 8. So for Java 7 and before, you might use a for loop like so. Say I want to iterate over this list of integers here, and I want to say print out all even numbers. It's not very difficult or complicated, like so, and we can just run that. So I'm iterating through my list using this for loop, and we can get the not very exciting numbers out there. So what we've done in Java 8 is we've added some new methods. So on the list now we have a for each method, but list is an interface, collection is an interface, iterable is an interface, but yet we can call for each on the list. So this is another feature we've added, a language feature we've added to Java 8. We can now add methods to interfaces. So we've added a for each method to iterable. And iterable takes an instance of consumer, and it will iterate over the iterator of the iterable and call action.accept on that consumer with each element as it goes. So that's our default method there. So we can essentially copy this piece of code here and stuff it like so. And we can run it again and won't get any very exciting output. The thing is, we've just raised the abstraction a little bit. You can use anonymous in a class if you want to, but it starts to get ugly pretty quickly, especially when I go on to the next example like that. The important thing here is now we've raised the abstraction, we can actually optimize underneath the covers because we're not doing it externally. So this for each implementation could be optimized to the specific list implementation here. The question is it? So let's just have a look at our arrays list in the Java code here. So we're looking in the JDK code here, and this is our method asList, and it's got an implementation called arrays list here. Now, if we want to optimize, we should expect an implementation overriding the default method of iterable. And in Java 8 code, we missed it. We forgot about it, but we have 8U20 coming along, so we can actually, let's see, I'm going to just open up my 8U20 source code here, and let's see if we have it in here. So, yes, we do. So I fixed this bug in 8U20, which should be coming on. We have a for each method specifically on the list, and instead of iterating over the iterable, we just iterate over the array instead, and that will actually be more efficient. Upping the level of abstraction allows us to monkey around over covers and optimize a little bit. So let's raise it a little bit more instead, and rather than for each, we can call stream. And this allows you to get a view over your list as a stream instead, and we can do the for each here, like so, and copy that same code in. Now that's not particularly interesting. It's virtually no different to before. But what we can do instead, notice what this is doing. It's essentially filtering out all the odd numbers. So we can call filter there and have a little lambda expression, like so, and we can get rid of that. And now we can compress this down too. Let's just copy this piece of code out and compress this down and change it to, once I get it right, we can change it to a method reference. Instead, we're compressing things down, shuffling things around, moving levels of abstraction up. That's not particularly very exciting. Why don't we instead sort of do something else like map integer to binary strings, say, and then rather than printing it out, we can collect, and let's join it all up with a comma-separated list. And I'm just going to do a little helper instead of the IDE. So rather than, we could all stuff that into the for each method if we wanted to, but we can use the Stream API instead and up the level of abstraction. I'll just print it out just to show you that it actually does work. Like so. And we should get our binary results of 1, 2, 4, 8, and so forth like that. So hopefully that's given you a little bit of flavor of the Stream API. I'm going to be talking about it more tomorrow. When you have that, you can also go parallel. I'm not going to get much into detail of exact under the covers today. That leads on to our next example, which is a bit more fun. So I came across this article, how mathematicians used a pump-action shotgun to estimate pi. And the motivation to do this was if there was a zombie apocalypse, we would lose the technology to calculate pi, but there would always be shotguns around to shoot the zombies. So what they did was they got a square of tin foil, And they shot the shotgun at it about 200 times, and they counted the number of pellets that hit the tin foil, and they counted the total number and the number that hit inside a circle, and the ratio of those two numbers you can obtain pi at. But we can also do this, arguably less fun, using the stream API too. It's an embarrassingly parallel problem as well. So here's how we can do Monte Carlo pi using streams. So I'm going to say, I'm going to shoot 32 million shotgun pellets at my square. I'm going to do this by using an int stream. I'm going to range over all the pellets I'm shooting, one by one by one. And then I want to set up a filter operation. In this operation, I want to get a random number generator, and I want to get the XY position of each pellet. So I'm going to create a random number X and a random number Y, and that's my pellet I'm firing, all 32 million of them. And then I'm going to say, well, is this pellet within the circle or outside the circle? And I'm going to turn true if it is and false if not, and then I'm simply going to count them all up. And then pi is the ratio of those two numbers, m over n times 4. It's that simple. Much simpler than firing shotgun, but less fun perhaps. Let's just run it. So we do get pi. It's not very accurate pi, 3.1415 for decimal places, say, but it does work. And it's embarrassingly parallel. I can actually go parallel here. Let me just time this run here. So I'm just going to run this and time it. Now, this is not how to micro-benchmark your applications. I'm being really naughty here. What you really want to use is something called JMH, which is in the OpenJDK Tools project to get proper measurements of your times, but I'm just using it for explanation purposes. So I get about 0.58 seconds to calculate pi here. But it's embarrassingly parallel. So I can stick a parallel here, get the same code, compile it, and run it again. And we get faster, 2x. So like that. Notice the real time has got lower, but the user time has got higher. That's because parallelism always takes more work. I'm using all the cores on my system to try and get the result faster, but the result should be deterministic in this case. I should get the same result, in a sense, going parallel or going sequential. Okay, so that's pi. Here's a link to the JMH stuff. If you want to look at that, that's how to benchmark properly. And Alexei Shiplev is probably swearing at me right now using Unix time, but that's all right. Okay, so am I okay for time here?
You want to do, you have one more.
I don't want to do the Nashorn one, I think. I will do that.
Go ahead.
Okay. So we also have Nashorn that George mentioned. And I'm showing exactly the same code I showed in Java using Nashorn for calculating pi. So Nashorn has really, really good Java interoperation. I think that's one of its sweet spots. It's excellent. Here we're calling Java code for streams in JavaScript. We're passing in JavaScript's version of closures to the Java, and then later on, Java's calling back in JavaScript. It's quite an entangled relationship, but it all works really well. And that's quite neat. It's very easy to run. There's a new command line utility called JDash, which will run the JavaScript. So let's just run that and see if it goes. And copy that. Okay, well, whoops. It's taking its time. It's not as performant in 8, but there's a heck of a lot of work going on now to make Nashorn extremely good in performance. They're doing a lot of work, and it's all going into Java 9, and I can run it in Java 9, and most of these things will get put into an 8U release, 8U40 later on, so the performance of Nashorn is going to get better, and I can run my Java 9 version. I'll run it again because it's got to warm up because I'm running a new VM. And it gets better. It's better than it was before. So performance is going to improve in Nashorn. The interoperability is great. You can use streams in JavaScript or Java if you want to. And you can go parallel too. Okay, shall we switch?
That's great.
Well, so I hope, one of the things that's hopefully a takeaway from this, right, aside from the fact that, oh yeah, that looks very nice, it looks, pretty easy to deal with, As Paul said, what we've aimed at is something that makes it easier for you to write things, makes it simpler, and makes the resulting code far easier for you to kind of understand and come back to and kind of get what this is doing. Far more declarative. And so I think there are a lot of nice aspects of functional programming that you now can take advantage of directly in Java. So I mentioned earlier OpenJDK. I talked about the JCP, right? And so I often get a question about, well, what are these two things, and how are they similar or different? OpenJDK is a community for developing the source code for the reference implementation of Java SE. So this was kind of the next step in the evolution of making it possible for people to get involved in the direction of Java. And so this has been around since, I believe, between 2006, 2007. The code, the original code from the Sun implementation of Java was contributed to OpenJDK. This is where our development happens now. So, and I think a very, very nice thing about it is this is not an open source model, which is we do a bunch of work behind closed doors and then we throw stuff over the wall and you can see it, but you don't see how it got there. This is actually something where you can go and you can go to the Mercurial servers and you can look at what's going on. You can look at the state of projects. You can see check-ins as they're happening. You can subscribe to the mailing lists and see feedback that is happening on reviews of individual check-ins. And I think that this is a tremendous thing. I think it's a wonderful learning opportunity, and it gives a lot of transparency. Not only in terms of seeing the resulting source code, but also seeing what were some of the thoughts that went into getting it to the place that it is. What are the kinds of things people think about as they're reviewing code in particular areas. And so this is something, if you haven't looked at it, I'd encourage you to. Transparency is one of the big things here. It's also this idea of collaboration in the Java community. I'm really pleased at the number of contributors that we have from different places. I should mention that in addition to my position at Oracle, I'm also the chairman of the OpenJDK governing board. So I'm always happy to see that moving forward. Going on, we see at this point top individual contributors, folks like Doug Lee and others, but also lots and lots of enterprises involved. This started out being mostly the kinds of people you would think of that have an interest in implementing Java. What we've seen now is that more and more there's engagement by people who are kind of expert users of Java. Right, and so if you consider yourself an expert user of Java, or even if you don't, this is a great resource for you. Okay. Is anyone familiar with Olo? Have you heard of that? So there's a great site out there called Olo. I think it's OHLOH. This is a place that collects kind of statistics on open source projects and communities. So you can actually go there and you can look up OpenJDK and you can see there this sort of independent body that's kind of gathered statistics on contributors and contributions to lots and lots of different open source projects. And if you go there, you will see that the numbers of contributors, the number of contributions that have occurred in OpenJDK has just grown and grown and grown over the years. It's quite dramatic. We're continually working on the infrastructure for OpenJDK. This is both in terms of things like thinking about the process of how we do things, but also in terms of making the actual infrastructure that we use to run the site and so on smoother. So how many people are used to or have looked at the Java bug system? Not a whole lot of people. This is something that existed for many years, but we about a year ago moved to Atlassian Jira, and so if you're used to Jira, you can go there and look at this. You can look at bugs, get an idea of what bugs are open. You can see when bugs are fixed, and so on and so forth. So that's also, I think, a great place to look at. And what I'd finally mention here is something called Adopt OpenJDK. This is a program or a group of programs that were done by some of the larger Java user groups around the world. I'd mention in particular the London Java community and SuJava in Brazil. These are quite large and vibrant organizations. I think SuJava has something like 40,000 members. And these are all Java developers who are interested in kind of learning about things that are going on. They've done a bunch of work in order to make it easier to sort of approach OpenJDK and understand what it's about and ways that you can potentially get involved or learn more about it. And then I think the final thing to mention here, right, this is back to what I was saying before, with Java 7, Oracle chose to designate OpenJDK as the reference implementation for Java. So basically what that means is that this is a level playing field. There's no, it isn't, in fact, the Oracle JDK has to live up to the standard set by OpenJDK, not the other way around. So anyone out there who's implementing Java, if there are questions about compatibility, OpenJDK is where you go to see what's right. Okay? We're going to talk very briefly, I know we're getting to the end of the time, but we wanted to talk a little bit about things that are coming in the future. Here again, I'm going to, down here at the bottom, just mention that we've recently revved the process for proposing new ideas for things that could be done in Java in the future. These are now in the Java bug system, in the JIRA. So you can actually go and look at proposals that have been made by OpenJDK members about new things that we could do. These are in general sort of described as kind of an idea without necessarily any context on exactly what kind of time frame it might come in. Some of these may be wild ideas that never get implemented, but a great many of them will. And in fact, all of the features that were in Java 8 came in through this process in a slightly earlier version. So they weren't in the bug system, but it was essentially the same kind of open process. So in 9, things I'd mention in particular, Jigsaw. Paul is working hard on that when he's not off having fun at conferences. And so as soon as he's done, I'm shipping him back. We also have some work on enterprise deployment. And what I mean by this is I quite often have companies that come and say, hey, we've got like 50,000 desktops in our company that are using a Java application, and we really don't feel like we have that good a handle on which versions are being used, and we want to stay on the latest secure version, but we don't want everyone to administrate their own desktop, and how do we do this? So we've been doing a bunch of work on this, both in order to let you leverage tools that are out there like Microsoft installers and things like that, but also in order to be able to get a better idea of tracking what things are being used in order to take particular applications and tie them to particular versions, and the other way around as well, so that if you know that there's a compatibility issue with a particular applet or application, you can say it's all right for this old version of Java to run that, but I don't want it to run anything else. So some good stuff going on there. Continual improvement to the JVM. This is both in terms of allowing you to have better isolation, but at the same time increase the amount of sharing. This is something that I think becomes even more relevant in the cloud, as people want to be able to share resources and get some kind of efficiency improvements there. Additional improvements to serviceability. So as you're doing that, you also want to have an idea of what's going on in there, have better transparency and understand what's happening in the VM. One other resource I would mention in this context is there's a small conference that is, I think, now in its 7th year, something like that, called the JVM Language Summit. This happens at the end of July, and it's quite small. It's invitation only, but all of the talks that are given there are made available on the web. And so this is quite a neat thing if you want to see people involved in implementation of languages like Scala and Clojure and JavaScript, Nashorn, meeting and talking with people who are implementing the JVM in order to help us understand what things we can do in order to make the JVM a great runtime platform, not only for Java but for other languages. It's a pretty neat thing to witness. All right, and then this is some things that are going out even sort of further into the future. Paul, do you want to say something about some of these?
If I want to get across all of this, I think that in Java 8 was a renaissance, and this is the industrial revolution happening in Java. There's some really key things around improving the performance of Java like what you might get with value types, which you can think of as structs, to enable you to lay out stuff in memory far more efficiently so you can iterate it without blowing your caches and stuff like this. So this is really exciting stuff. The stuff with like Project Panma and FFI is to get the VM to communicate better with your OS much more efficiently and much, much better developer-wise than you would do with JNI. There's some very key features of the VM and hotspot that have to come about to make this. So some might trickle through earlier and percolate up later on as we progress through 9 and 10. And this enhanced volatiles is something that Doug Lee's working on, and I've done a bit of work on, and it's allowed us to replace something called sun-misc unsafe, or usages of that, with safe but performant alternatives. So we could replace all the sun-misc unsafe stuff going on in Java use of concurrent libraries with this public and safe API, and other people, like people who write Disruptor and other concurrent frameworks, can do exactly the same. So when we remove sun-misc unsafe in Jigsaw, we have this public API that people can use instead. So I think we're...
Good. So having mentioned that, I wanted to just sort of name a couple of things that you can do to help and that you may not be aware of. One thing I'd like to point out for those who don't know about it is the work that we do, the releases that we're working on actually have publicly available early access builds. And these are available on about a weekly basis. So basically, if you want to go and try these out in advance, you can do that. Now, why the heck would you want to do that? Well, basically, you'd like to make sure that your application is going to be able to run smoothly on this. And if it isn't, we'd like to make sure that we fix any issues that keep that from happening. And of course, we can only do that if we're aware of issues. And Java is used by so many people in so many different things that there's no way, as great a job as people do, testing. The best thing that we can do is to have everyone out there helping to test and reporting issues. And the earlier you report an issue, the more likely it is to get fixed. So please try these out. This is something I'd especially stress as Jigsaw starts to come into 9. Paul was mentioning things like sun-misc unsafe, no longer being accessible. There are other things like that where we're doing a bunch of work to try to figure out, the things that are in the sort of in-between zone, right, where they're not things that are part of the spec and are guaranteed, to remain compatible, but they are things that a large number of applications out there have traditionally used and have some kind of reliance upon. And these can be both things that are, just API, or they can be things that are more subtle, like behavior of API. And so, we'd really like to make sure that there is something that provides a smooth transition, and you can really help us by trying things out and telling us about it.
And patches and tests.
And that's right. And even more than bug reports, patches and tests are welcome as well. So please check this out. And the final thing, I'm actually just interested. I like to get kind of an idea of how many people are using different versions. So how many people do we have out there who are right now primarily using Java 7? Okay. How many people are now primarily using Java 8? Okay. So some of you have homework to do. How about Java 6? Still a few of those. And how about 5 or earlier? Shame on you. Okay. All right.
It's not his fault.
Good. Well, I would actually say that I think you guys are a little bit behind. And why I say this is that, most places that I go and ask this question, I'm actually, kind of amazed. There's usually quite a number of people who are using, what I didn't ask. How many people have downloaded an early access build of 9 and tried it? All right, extra star for the man in the maroon sweater right there. Good job. Okay, so anyway, I do think that this transition is one that you should pay attention to. Please do try it out. By and large, everyone who's tried out 8 has come away with a very, very positive experience. So with that, I'd like to thank you very much, and I hope you have a wonderful conference.
Thank you.